Here goes section 3.3, proving lines parallel. Our objective for today, I can use the angles formed by a transversal to prove two lines are parallel. Recall that the converse of a theorem is found by exchanging the hypothesis and conclusion. So remember the converse of something is if Q, then P. Okay, we're switching the hypothesis and the conclusion. We are going to take the converse of what we learned from 3.2 and we're going to apply that today in 3.3. Postulate 3.3.1, converse of the corresponding angles postulate. This is going backwards from the corresponding angles postulate. This is saying if we know that angle 1 and angle 2 are congruent and that those are corresponding angles. So if we have corresponding angles that are congruent, we know my two lines are parallel. So here's our first example. Use converse of corresponding angles postulate in the given information to show that L is parallel to M. Well, they tell us that 4 is congruent to 8. So if 4 is congruent to 8, those are corresponding angles. And if corresponding angles are congruent, that means that the lines are parallel. That's the converse of corresponding angles postulate. That's what we just talked about. Now this time, we have to do a little bit of work first. Okay, here's the given information now. And notice we're talking about angle 3 and angle 7, but they don't tell us exactly what angles they are. They give us an expression. They give us what x is equal to. So, as you might guess, we plug 30 in for x into both of them, and we see that they both equal 40. Since they both equal 40, that means they are congruent, and since they are congruent, that means the lines are parallel. That is converse of corresponding angles postulate. Okay, I want you to try this one out, see what you can do. Okay, of course, we plug in the 13. We notice that they both equal 77. Since they are corresponding, they are congruent, which means that our converse of corresponding angles postulate is true and L is parallel to M. Moving on, parallel postulate. Through a point P not on line L, there is exactly one line parallel to L. What this is really saying is that for any line that we have, if we have a line, okay, here's a line L, and a point P, there is exactly one parallel line that I can draw through P that will be parallel to line L. Okay, there's exactly one line that's parallel to L. Here are other three theorems for today. We've got converse of alternate interior, converse of alternate exterior, converse of same side interior. Okay, remember these are the converses. So everything that you learned before about the regular alternate interior, alternate exterior, same side interior, you're going to use that information, but we're going backwards on it now. Okay, remember before we said if the lines are parallel, then alternate interior angles are congruent. Well, now we're doing the converse of that. We're saying if the alternate interior angles are congruent, then the lines are parallel. So the important thing to remember here is that we are using this to say in our conclusion that the lines are parallel. So we're using the converse to show that lines are parallel. Make sure you know the difference. If we already know the lines are parallel, that's the regular ones that we learned in 3.2. If we're trying to prove lines parallel, that's where 3.3 comes in our converses. So let's take a look at this one. We've got angle 4 is congruent to angle 8. Well, angle 4 and angle 8, what type of angles are those? That's a alternate exterior angle pair. So we have alternate exterior angles there, and since alternate exterior angles are congruent, that means that our lines are parallel. Next one is the same idea that we did before, where they give us the angle measures in expression form and they tell us what x is. We plug it in, we figure out that our two angles are 58 and 122. Notice that we're talking about 2 and 3 here. You should know what type of angles those are. If we add those together, they're going to equal 180. Since they equal 180 and they are same side interior, we can now use the converse of the same side interior's angle theorem to show that R is parallel to S. Next one, I want you to try it out. Look at what type of angles you have, plug in the value for x, and see if this works and we can prove that R is parallel to S. Okay, so if we plug in 50, that's going to give us 100 and 100. If we look, 3 and 7 are alternate interior angles. Since they are alternate interior, we use the converse of the alternate interior angles theorem to show that R is parallel to S. Okay, now moving on, we need to create proofs based on these postulates and theorems. So they give us the given. P is parallel to R and 1 is congruent to 3. And we're trying to prove that L is parallel to M. So what you really need to think of is what can we do with the information that's given? Okay, what can we do with the information that's given? Well, if I know that P is parallel to R, okay, P is parallel to R, and I know that 1 is congruent to 3. Okay, well, what we can do here is we have a pair of parallel lines cut by a transversal right here. So using our alternate exterior angles, we can say that angle 2 and angle 3 are congruent. That's alternate exterior. That's from 3, 2. So we're going to use that alternate exterior to say that those are congruent, and then we can go from there. So let's take a look at what they do. You'll see our picture in the corner there. Step 1 is always our given. Step 2, like I said, alternate exterior angles theorem. They're saying that 2 is congruent to 3. 1 is congruent to 3, that was given. So now, if you look at it, we know that 1 is congruent to 3 and 2 is congruent to 3. So if 1 is congruent to 3 and 3 is congruent to 2, that's transitive property. We can now say that 1 is congruent to 2. And now since 1 is congruent to 2, what type of angles are those? Those are corresponding angles. So once we have corresponding angles that are congruent, we can use the converse of the corresponding angles postulate to say that L is parallel to M. Okay, so take what you have at the beginning and go from there. Do what you can. We had the picture. We noticed we hadn't used the number 2 yet, the 2 angle. So we had to use that some way. Well, we knew P and R were parallel, so we can go alternate exterior, and it kind of falls in place from there. Okay, I want you to try this one out. Your given is 1 is congruent to 4, and 3 and 4 are supplementary. I want you to prove that L is parallel to M. See what you can do. Okay, so if we take a look, and I put the picture up in the corner there again. First step is always the given. Okay, 1 is congruent to 4 in this case. Because 1 is congruent to 4, that means 1 is equal to 4. Remember, that's our definition of congruent angles. It says that congruent means equal. So we're now saying that 1 is equal to 4. Well, we also know that 3 and 4 are supplementary. That was our other given. So since 3 and 4 are supplementary, now what can we do from there? We can say that 3 plus 4 is equal to 180. Now they have the wrong thing down here. They have transitive property of equality, but we know that this should be definition of supplementary. Okay, so that should be there. It's going to erase when I click the button, but you know that that one should be definition of supplementary. So moving on from there, we can substitute. We already said that 1 was equal to 4. This is why we went from congruent to equal. We can say that 1 is equal to 4. So we replace the 4 with the 1. Now we're saying that 1 and 3 add up to 180. That is our substitution. Now, 2 is equal to 3. Why is that? That's vertical angles. Okay, we've got vertical angles. Because we know eventually we want to say that L and M are parallel. We can't do that with 1 and 3. 1 and 3 are not a pair of angles that we know of. It's not alternate exterior, alternate interior, same side interior, or corresponding. So we need to get angles that are. Well, 1 and 2 are for lines L and M. So we have 1, we need a 2 in there. So if we say 2 is equal to 3 because of vertical, now we can substitute again. We can substitute the 2 in for the 3. So now we have 2 plus 1 is 180. Since 2 plus 1 is 180, now we have converse of same side interior, and L is parallel to M. Okay, here's your lesson quiz. Pause it, try it out, see what you can do. Okay, let's take a look. 4 and 5. Converse of alternate interior. Remember, we're proving lines parallel, so it has to be the converse. 2 and 7, those are alternate exterior, so converse of alternate exterior. 3 and 7 are corresponding, so converse of corresponding angles postulate. 3 and 5 are supplementary, that is the converse of same side interior. Good. Last one. We want to prove that P is parallel to R. How are we going to do that? Try it out. Okay, of course we're going to plug in the 6. Okay, when we plug in the 6, that gives us 50 and 50. If we look back, we're looking at this one. Okay, last one. We're still going to use that figure. Okay, so we're looking at angle 2 and 7. If you look right now, 2 and 7, we see our alternate exterior. Keep that in mind. So I want you to try this out. Here we go. You plug in the 6. We get that both angles are 50. 2 is equal to 7, so 2 is congruent to 7. Converse of alternate exterior says that P is parallel to R. So this is the converse of what we did in 3-2. Hopefully it makes sense for you in 3-3.